I'm here today to share with you about our Xeno-Free 3D printing course at TU Berlin, where we designed this course to help students to understand to practice bioprinting without animal-derived materials. So I will start this with this slide that I took from Dr. Jens Kurek for his presentation. It's a quote from Max Planck that he said that science advances not by change old minds, but as the new generations adopt new ideas. So, and later on, we could see Thomas Kuhn describe this concept as paradigm shift. And that's a fundamental change in how science moves forward. And with this belief, I think that's everybody that gathered here today in this webinar, like interesting to change the new generations and move forward with science. The overview of this presentation today, it's simple. I just gonna talk quick about our course inspiration, this Xeno-Free 3D bioprinting, and then I'm gonna present what we did in the past course, in the first course, and what we learned along the way, and how we design the future course. So the concept of the course was like inspired from our PhD student in the lab, that's RMED research. He developed a chemically defined medium for liver cells line, the HU87. And with that, he could design a Xeno-Free bioink to bioprint a simple liver model to test drugs, toxicity of the drugs. And based on this work, we create the 1-week practical course aimed at master students at TU Berlin. And you could introduce to these students cell culture, bioprinting, and toxicity testing without using animal-derived components. And the first course basically the first course basically we teach the students how to culture cells, how to subculture cells, how to cryopreserve the cells, and how the cells behave in different conditions. And then they observe the 3D bioprinting and do some toxicity testing. So this is like the overview of the course. So the course had like some lectures before the hands-on in the lab. So the first day, I will go through which teach in the lectures to the students, but just the overview of the course. The students, the first day already have like learn how to cultivate cells in chemical defined medium, and then they seed the cells to count and check the cells morphology in the microscope, because some students come without have experience in cell culture. So we use this opportunity for them to learn the technique. So they seed the cells to use the cell detachment, and then they freeze these cells in the first day in different conditions of the media, and then they saw, they count, and they could do some viability test with these cells. In this first course, the tutor did the bioprinting, and then the students work with the model, testing the cell viability in the 3D model. So this is the structure that like the workflow of the first course that was offered about 2 years ago. And the lectures that was presented in this course talking about animal components in cell biology. So this lecture was given for Dr. Kurek, and then he explored about antibodies, FBS, base membrane extract, so how the science use these components in the cell culture, and they present alternatives, non-animal alternatives, comparing like what we have most of the days in cell culture. And he explained to students about polyclonal, monoclonal antibodies, introduced about animal-free antibodies by phage display, giving alternatives to the students too. During the cell culture lecture, we're talking about the HeLa cells because we're talking about the ethics in science to use materials, permission materials, and bring the HeLa cells to the students, the history about the cells to the students. And then we really teach the students the type of extraction that need to be made to have FBS to work in cell culture, the effect, the composition, how the batch-to-batch variations, the lack of reproducibility used in FBS. We explore, for example, with the students, this chimeric system when you use mammalian cells, human cells with FBS. So creating this chimeric system that can compromise to translate like this to the human diseases or human condition, physiology. So we discuss a lot what's behind the FBS, and not just show like this, but we present alternatives to FBS too. For example, human platelet lysate, chemical defined media that the students use in this course. We present the FBS free database. So it's a very wide conversations and material that we give to the students during the lectures to complement during the hands-on in the lab. So in the bioprinting, this course, the first course, the tutor print the model. The students observe, of course, follow the printing, and then but in the lectures, we teach the students like different bioprinting technologies, introduce the basics of bioprints, the 3D bioprinting setups. We're talking about inject bioprint extrusions, stereography, to have like an overview, the different techniques that then can be used. And finally, the students have a lecture about ethics, showing the students the major ethic theories, talking about animal ethics, and of course present the 3R principles proposed by Russell and Burt, to give the students, to promote students like a critical thinking about the animal use in research. So all these like lectures is to give like a base to students to understand like what we can do in the lab and to thinking about the research itself. So after the lectures, students went to the lab, and then, as I mentioned, they try, for example, freezing the cells with different conditions. So, for example, they use this chemically defined medium with BMSO, and then they thaw and they check in the microscope, and then check, for example, they did the life and death assay and check in the fluorescence microscope. And they try with the different conditions, adding 5% dextran or pluronic F68. So they compare these not just in the microscope, but they did the XTT assay, just the metabolic activity of the cells. So with these, they have like opportunity to have the hands-on in the lab. And this is like the cells that was freezing and thawed. So yeah, and the second moment that after they print, they did the same. So, but they use like the models, and they treat the models with like 70% ethanol. So they incubate the models within 1 minute and 10 minutes, and they check the cell viability, and they do the XTT to test the cell metabolic activity. So they can see that like 10 minutes we cannot see because the green, sorry, the green it's like live cells and the red is dead cells. So they can see through the microscope the toxicity of the ethanol and another type of DS in the metabolic activity during the XTT. So in this course, this was the first course. The first day of the course, the students uh, receive like 2 questions in the beginning of the course. So, and these questions, like Ahmed was brought from his JRC summer school of non-animal approaches in science in Italy, and he had an idea to bring this to our course, to bring the discussion with the students, and actually was a very good idea. But we present this in the first day of the course, and then they have their own opinion. They say for them, and then after the course, they're gonna see during the course with learning about all the lectures and the lab if they change their opinion or not. So, but in the end of the course, not only this for them to thinking about these questions and see if the opinion change or not for themselves, we separate the students in 2 groups. One should be the group yes and one the group no. So they need, in the end of the course, create a debate. So the group needed to say yes for both questions. They need to defend that. And the other group need to say no for both questions and defend that. So they debate with each other. So they have the arguments, 5 minutes each group, and then they need to reply in 3 minutes, and then summary in 2 minutes. And it was very interesting, this discussion, to see how the students could develop and do the search, extra search, of course, about the topic to bring this discussion among the colleagues in the course. So was very encouraging students to think about the scientific progress, thinking about ethics, and thinking about the alternatives to animal models. So it was very interesting discussion. And after the course, we always give the students a questionnaire to know about what they're thinking about the course, what can improve. The questions like how they feel during the course, if the script was good, what they like, what they did not like. And one of the questions is, what do you think we should consider for future courses? What you like to see? And here's just a few samples of the students. So some said it's good as it is, and some liked the course and said you should have more students because the course is good. Could be 2 weeks to learn more. And some of them said that maybe you can print their model themselves, but to have like a little bit issue of time. So when we're thinking about all this feedback, and the next semester, we try to adjust a bit the course according to the students' feedback. And we decide to introduce the computer-aided design, so where students could have the computer, how to create the 3D model before the bioprinting itself. So they start to build like a 3D model, use like a CAAT. It's like a simple software, and just for practice. So the students, they need to make their own keychain, and they print in the FDM printer. And that's really very nice because they're so happy with the and then to show their creativity, what they do, and they have like these kind of the core souvenir to bring home. But these engage students to this type of activity. the design thinking, like what they can create, the creativity part. And of course, because it was interesting what the students ask about, they print themselves, so they prepare their own bioink. So we teach them how to prepare, and they print their own model. So this is a simple, we call like a waffle model for the bioprinting. So they print the model and they cultivate the model, and then they did the cell viability, the life and death assay, and the XTT to check the metabolic activity of the cells after ethanol treatment. And this second course, we need to remove, for example, the cryopreservation, because they need more time in creating the models, prepare the bioink, and then put their hands on in the bioprinting. So I think that this is a very good experience for them. They could learn better this way. So, and then after this course, of course, we ask the feedback again, and you always learn with the students. And again, some of them said that like to have longer, to have more fun, because it was very fun. And some of them suggest that we could compare the 2D and 3D cultures with the cells and test some drugs, for example, toxicity of the drugs, and listen to students. So the next course we change a bit. So that's what we want to add this in the future course, to add the comparison between 2D and 3D cultures, and discuss the advantage of the 3D model versus 2D culture. So with these, we're gonna have like 2 days of lecture, and the rest of the time of the course, the students will be working the computer and the modeling. They will prepare their bioink. They're gonna have, of course, introduction to the cell culture, and they still have time to work in the computer tasks. So, and then they will seed the cells in 2D, in the plates of 2D. They will design the model, do the 3D bioprinting, and then we decide to use 2 drugs for analysis, one with low toxicity, one with high toxicity, and then the students can check, analyze the cells. And so we reduce the lectures, but we still cover what we cover in the first course, as I mentioned in the beginning of the presentation. We're still talking about the cell culture, the bioink, the bioprint techniques. We're still talking about ethics, about the FBS, the use of, and then gave the students alternatives. And we do the introduction with bioinks and cell culture. And in the computer design, they still do the key chain. It's a very fun part and important for them. And they have like software that they can prepare 3D models for medical data, and they prepare their own model to print. So the students will have hands-on in different parts of the course. They're going to be more in the lab, and they have more tutorials in the computer. The hepatotoxicity test using, for example, a drug with low toxicity and high, and they can learn how to calculate IC50. And we decide to bring back, because the last course we did not have the debate on the first course, but we decided to bring back the debate because the debates bring a lot of develop of the critical thinking and the understanding, and the students needed to understand the different um, um, sections that we teach during the course. It's very enriched for them. So that's what we decide to do this course in the future. So this course, it's like we are bioprinting lab, so you have like the equipment, we have how can I say, um, projects working bioprinting daily in the lab. But to make this course, uh, just to have an idea, the materials that you need or what we use for this course in general. So for the cell culture, of course, you need a biosafety cabinet, incubator, microscope. One thing when you're talking about chemically defined media, it's a little bit more costly, but it's worth to work with the CDM. And of course, you need the consumables, plastic plates, pipettes, gloves for the students, reagents for the assays. And we have this bamboo level mini print for the FDM for they to print their keychain. And we use this incredible plus printing. This is the old bio printer, but we have in the lab and use based for the students, for the course, and of course the bio ink materials that we use in consumables for the bioprinting. So this is a course that, like, I would say that the cost would be around $5,000, $6,000 for a year, the course. So because we did like the 3 or 4 weeks a year, and we have like a space limitation. So in the beginning, we accept 6 students, but now we accept 8 because we have high demand. The students really interested in our course. So you can train the students in 2 semesters at TU Berlin. So, and for this course, we have basically 4 people working the course. We have the Dr. Kurek. We have the brain of the course, that our PhD students, that Ahmed, me, and we have like a teaching assistant student. So that's a course that we improve along the time. Always have like room for improvement, but I think that the format now, we can give a lot, I would say, background for the students about the animal alternatives in research and biomedical research, and they really enjoy the course. It's hands-on. They put their effort there, and then it's very reward to see the students in the end of the course. So this is basically what we offer as a Xeno-Free 3D bioprinting course at the TU Berlin. As I said, this course is for master students. But because we're talking about education and alternatives, how you can approach the students, I just like to mention that our lab give another course. It's not bioprint, but another course about nucleic acid course. And this course is FBS free. So we work with cell culture, and we just published last month about this course. So everybody can have access to this publication. We describe every detail that we work in this course. The students grow HeLa cells in chemically defined media, so FBS-free, and they do nucleic acid technologies devoid of animal components during the course. So, for example, this course, the nucleic acid technology has been offered for over 20 years, and of course, you use FBS back then. And this year, we fully transitioned the course for FBS free. So students learn how to culture the cells, passage the cells without using trypsin, using triple E. They transfect with sRNA, with fluorescence sRNA, and they can check this at the microscope. This is like a student result, the student's data. And another technique that we use, another methodology that we use in the course is dual luciferase assay. It's qPCR, QRT-PCR, and the Western blot. So the only thing in this course that's like is just the primary antibody from the target that it's a monoclonal antibody. The secondary and the actin, it's a phage display antibody. So this course basically very, very little animal-derived components in this course. And even the Western blot, to block, they use the soy milk to block the membrane of the Western blot. So we could make this course very attractive to the students and show them that like it's possible to do experiments in biomedical research without using animal-derived components. And so we often said that education doesn't just prepare us for the future, it empowers us to create it. And this is the core of our vision, like to give the students, the next generations, that they can create biomedical research more ethical, with innovation, and free from animal use. So I think that with initiatives like this, and we create like a way to show and creating possibilities to the student have access that we can doing biomedical research, avoid the use of animals, they can bring this in the future. As you said in the beginning, the paradigm shift can start happening at this way. And yeah, so before I close, I would like to thank everyone. Of course, Dr. Jens Kurek, Ahmed, that is the brain of this bioprinting course, Matze from our lab, everybody from our group, that everybody, when you make a course, a lot of people involved too, to prepare the course and be nice with the students around. And of course, big thank you for master students that attend our bioprinting course, and it was very real for us to see them learning and growing in a good direction. So thank you very much, and thank you for your attention.